Hello and welcome to TQS. In this video, we will present the powerful features available in the system for the structural design of reinforced concrete slabs. The modeling of the slabs of a building is done graphically and with 3D visualization in the structural modeler. The contours of slabs formed by beams or free edges are automatically detected. In TQS, you can design a wide range of slab systems, including solid, flat plate and flat slabs, ribbed and waffle slabs, and specialized systems like lattice, precast, composite, and prestressed. For waffle, ribbed, and lattice slabs, whether one-way or two-way, the filler blocks are positioned and distributed in the structural modeler automatically. It is possible to define different concrete cover values per slab or per floor. Concrete strength can be differentiated by floor. Loads on slabs can be point, line, moving, distributed over an area, or uniform. Loads can be defined directly in the structural modeler and also imported from a text file or BIM models. In structural analysis, slabs are modeled as a grid, with discretization fully controlled by user-defined criteria. In Model 4, the slabs are discretized into a grid model for each floor, and the results are transferred as loads to the beams of the spatial frame. In this case, only the rigid diaphragm effect of the slabs is considered in the overall behavior of the building. In Model 6, the slab grid is incorporated into the spatial frame, forming a complete spatial model of beams, columns, and slabs. In this case, both the rigid diaphragm effect and the flexural contribution of the slabs are considered in the overall behavior of the building. It is possible to define plastic hinges in the slab-to-beam and slab-to-column connections in different ways. The effect of the torsional moments in the slabs is considered using the wood armor method. You can define drop panels on slabs where the mesh is refined for more accurate calculations near supports. Deflection and concrete crack width evaluations in slabs can be performed using an approximate linear analysis or a refined nonlinear model based on moment curvature relationships, accounting for concrete cracking, reinforcement, and time-dependent deflection. It is even possible to calculate the concrete cracking after masonry construction. Slabs are designed using the envelope of bending moments, axial forces, shear forces, and torsional moments of all combinations of ultimate limit state by an automatic process. In Model 6, the global second-order effects and the envelope of the repeated typical floors are considered. Slab drawings are generated automatically and can be separated for each direction. TQS has a graphical reinforcement editor to assist in checking the design and detailing of slabs. The system works with the concept of force strips generated on each alignment of bars in the grid. In the editor, it is possible to view the force diagrams and all the force strips, which contain information such as bending moment in the strips, required reinforcement, width and effective depth, and provided reinforcement placement. These strips are automatically homogenized and grouped to achieve optimized detailing. In the editor, the homogenization of the force strips can be edited and adjusted interactively. Based on the force strips, longitudinal reinforcement for pure bending is designed in the main and secondary directions of the slabs. In floors where axial forces are significant, such as when slabs are pre-stressed or subject to temperature effect, shrinkage, or inclined geometry, the slabs are designed for combined axial force and moment. Bar diameters and quantities are automatically selected for each force strip. In the case of lattice slabs, joist selection and additional reinforcement detailing also occurs through an automatic process. A scheme with base and complementary reinforcement can be adopted to generate a more economical distribution. Bar anchorage of the longitudinal bars is calculated automatically. The editor also graphically indicates the differences between provided and required reinforcement, helping to identify over or under reinforced areas. TQS performs shear and punching shear design. It is possible to view the values of the design strength and required strength, critical perimeter geometry, and the reinforcement area when necessary. The need for reinforcement to prevent progressive collapse is also verified. In addition, the editor offers tools to join, create, move, match lengths, and mirror bars, and set dimensions. The final output is a complete slab reinforcement drawing tailored to the engineer's needs and ready for plotting. For lattice slabs, it is possible to generate material takeoffs for all their constituent elements. Design, detailing, and drawing are guided by a series of criteria that can be easily edited by the engineer. TQS can account for openings or shafts in slabs. It is possible to use pre-stressing in slabs and wide beams. The reinforcement editor also provides calculators for pure bending, combined axial load and flexure, and shear, helping with detailing verification. TQS has an editor for infill blocks and trussed joist reinforcement. Slabs can be modeled on an elastic base for mat foundation and piled mat foundation simulation. TQS allows modeling columns that are directly supported by slabs, and also to model, design, and detail stairs, landings, and ramps. To learn more about TQS, visit our website. Thank you.